There's a comet out there that breaks the rules. It has no tail, no glowing cloud of dust, no visible trace of the things that make comets, comets. Yet it moves like one, follows a comet's orbit, and sings with the chemical fingerprints of water and carbon dioxide, molecules that whisper of ice and sunlight. Its name is 3 Atlas, and if what astronomers are seeing is real, it could rewrite what we thought we knew about how the universe works. On October 14, 2025, the Transiting Exoplanet Survey Satellite, better known as TESS, released a dataset that would send shockwaves through the astronomical community. Over 9,000 images, painstakingly stacked and analyzed, revealed a single startling truth: Atlas has no tail. To the world's most sensitive telescopes, it appears not as a diffuse, glowing wanderer, but as a perfect point of light, indistinguishable from a distant star. But here's the paradox. While optical telescopes see nothing, the James Webb Space Telescope and other instruments detect water vapor, carbon dioxide, and escaping gases, all hallmarks of an active, icy body. How can something be venting material into space without showing the faintest trace of it? How can it breathe but not bleed light into the dark? Some call it an observational glitch, a trick of geometry, an artifact of instruments. Others whisper of a cover-up. A handful of researchers suggest something even stranger, that 3 Atlas might not be a comet at all. Over the past weeks, fragments of information have surfaced, hints that NASA's Psyche spacecraft may have had the object in its view during its cruise phase. Yet no images have been released. The official archives are silent, and in that silence, the mystery deepens. Tonight, we're going to follow that silence through conflicting datasets, unconfirmed sightings, and the tangled machinery of space science itself. We'll ask hard questions. Was Atlas always this strange? Did our instruments fail us, or is something deliberately being hidden? Could we be witnessing a new kind of object? One that challenges the line between the natural and the engineered. And as we explore, we'll cross paths with other cosmic anomalies. A star that beats like a mechanical heart every 44 minutes, and a neutrino that struck Earth with impossible energy. Together, these stories paint a portrait of a universe far stranger and perhaps far more aware than we've dared to imagine. So stay with me, because by the time we reach the end, you might find yourself asking not just what Atlas is, but who or what might be watching from the dark. No tail. Why that breaks the simple comet story. Imagine the night sky alive with telescopes, dozens of domes gliding open in the cold, hundreds of instruments pivoting toward the same patch of darkness. Ground-based observatories in Chile, Hawaii, and the Canary Islands. Spacecraft orbiting above Earth's atmosphere, their sensors chilled to near absolute zero. All of them focused on one target, an object that should be simple, predictable, and bright. Comets have always been cosmic performers. As they near the sun, their frozen interiors heat up, releasing gas and dust that scatter sunlight into a breathtaking tail, the comet's signature. But when 3 Atlas swept into view, the performance never began. The Transiting Exoplanet Survey Satellite, TESS, had spent months collecting over 9,000 images of the object. When the team at MIT and NASA stacked those frames, a process known as co-adding, they expected to see at least a faint blur, the coma, the halo of evaporating ice, or the thin, glowing filament of a tail. Instead, the image sharpened into a single dot, a point of light with no spread, no cloud, no extension. To the trained eye, that single dot was catastrophic, not because it was faint, but because it was too perfect. TESS had captured what astronomers call a point source, the same optical pattern produced by distant stars. When the researchers examined the light profile, it fell off precisely as it would for a star. Sharp, symmetrical, and clean. No trace of diffuse material. If Atlas were a true comet, it would behave like every other comet we've ever studied. The nucleus would be shedding fine dust grains, forming a coma hundreds or thousands of kilometers wide. Sunlight would scatter off those grains, creating a tail that points away from the sun. Yet, in image after image, the TESS data showed nothing. The analysis went deeper. Researchers measured the radial brightness profile, how the intensity of light fades from the center outward, and compared it to models of comets, asteroids, and stars. The result was conclusive. Atlas's light curve matched that of a star, not a comet. That finding alone was enough to spark debate across the scientific community. Could TESS's optics have washed out a faint tail? Could calibration errors have masked faint dust? The team accounted for every variable. Stacking thousands of frames boosts sensitivity far beyond what any single exposure can see. If even a wisp of dust existed beyond a certain threshold, it would have appeared. But it didn't. That's when the contradictions began to pile up. Other instruments, particularly the James Webb Space Telescope, reported something else entirely. Infrared spectra revealed emissions from water vapor and carbon dioxide, active volatiles. These gases can't exist without sublimation, the very process that should create a visible tail. So why was one of the most advanced optical telescopes in existence blind to what infrared sensors were shouting about? One explanation seemed too convenient: geometry. Perhaps we were looking directly down the tail, so it appeared foreshortened, an illusion of perspective. But the odds of such perfect alignment across multiple observations were astronomically low. Others proposed that the dust particles were unusually large, millimeter-sized or more, and thus inefficient at scattering visible light. That might explain the darkness, but not the behavior of the gas. In the data, the contradictions were irreconcilable. If Atlas were active, it should be messy, glowing, and dynamic. If it were inert, it should be silent in every spectrum. Instead, it was both, chemically alive, optically dead. The more scientists looked, the stranger it became. Stacking more frames didn't clarify the picture. It only deepened the mystery. There was no gradient, no subtle haze, nothing that could be coaxed out even with aggressive image enhancement. The TESS team published their results publicly, inviting independent verification. Astronomers worldwide downloaded the data, reran the analysis, checked the math. The outcome was the same: no tail. The implications were staggering. Because if this was true, if a confirmed, chemically active body could appear as a perfect point source, it meant something fundamental about our understanding of comet physics was broken. Every comet ever observed has followed the same pattern: approach the sun, heat up, release volatiles, form a coma and a tail. It's a sequence so reliable that astronomers use it to track evolution, estimate composition, even date ancient collisions. To find one that defies that pattern isn't a minor anomaly. It's a declaration that we've missed something essential about how these objects behave, and the more they probed, the deeper the contradiction ran. The numbers didn't just fail to align, they actively opposed one another. Optical observations denied what infrared spectroscopy confirmed. The most sensitive telescope to faint light saw nothing, while instruments tuned to molecular vibrations recorded a storm of chemistry. Somewhere in that data, a lie was hiding, either in the instruments, the assumptions, or in the universe itself. Because if this object truly has no tail, no coma, and yet bleeds gases into space, then Atlas isn't behaving like any comet we've ever known. It's something else entirely. Part 2. Cross-instrument contradictions. When the sky disagrees with itself. In science, contradictions are supposed to be temporary. You collect more data, refine your models, and eventually the pieces fall into place. But sometimes they don't. Sometimes, each new observation only widens the gap between what you see and what you understand. That's exactly what's happening with 3 Atlas. The first red flag came from the James Webb Space Telescope, a machine so sensitive it can detect the heat from a single human hand on the moon. Webb's infrared spectrographs saw unmistakable signs of molecular activity around Atlas: carbon dioxide, water vapor, volatile compounds streaming off the surface. The data showed emission lines, precise fingerprints of molecules vibrating and rotating in space. By every measure, this object was active, alive with sublimating ice and gas. Yet to optical telescopes on Earth and in orbit, Atlas was nothing but a point of light. No spread, no shimmer, no dust. It was as if 2 different universes were being observed, one rich with chemical chaos, the other a pristine, empty void. To understand the contradiction, you have to consider what each instrument actually sees. Infrared telescopes like JWST don't care about reflected sunlight. They detect heat, the faint glow of molecules themselves. Gas molecules emit infrared light when they vibrate or rotate, and Webb's sensors are tuned to those specific wavelengths. When Webb looks at Atlas, it's not seeing sunlight bouncing off dust. It's listening to the molecules sing. Ground-based telescopes, on the other hand, see light, the photons that sunlight reflects off dust grains. For them, no dust means no glow, no tail. So if Atlas is indeed shedding gas but little or no dust, the 2 types of observations could both be right, just measuring different realities. But here's the problem. In the physics of comets, gas and dust are inseparable. When sunlight heats ice, it vaporizes into gas, and that gas drags tiny grains of dust with it into space. You can't get one without the other. The dust gives the comet its visible structure. The gas gives it its chemistry. If we see only gas, something fundamental is missing. Astronomers tried to reconcile the 2 pictures. Maybe the dust grains were unusually large, millimeters to centimeters, too big to scatter light efficiently. Large particles don't move far from the nucleus either, so they might form a compact envelope invisible to optical instruments but still produce detectable gas through sublimation. That's plausible, but even then, the stacked TESS images should have picked up something: a faint haze, a soft shoulder in the brightness profile. There was nothing. Geometry was another suspect. If Atlas's tail happened to be aligned directly toward or away from Earth, it would appear foreshortened, compressed into a single point of light. Astronomers have seen this before with certain near-Sun comets. But in those cases, the alignment is brief, lasting hours or days. The no-tail condition persisted for weeks across multiple instruments with very different vantage points. The odds of perfect alignment every time are astronomically low. The simplest explanations were collapsing under their own weight. What if the activity itself was intermittent? Suppose Atlas isn't venting gas continuously, but in bursts, short, unpredictable pulses. If JWST happened to catch one of those active windows while optical telescopes observed during a quiet phase, their findings would appear contradictory, even though both were accurate snapshots of a changing object. That might explain the mismatch in timing. Webb's infrared observations were taken in mid-September, while the TESS dataset spanned early October. Could Atlas have gone quiet between the 2? Possibly, but even intermittent activity leaves traces: faint halos, residual dust clouds, jets frozen in motion by solar wind. Deep stacking of the TESS images should have revealed at least a ghost of that activity. It didn't, and that's when attention shifted to another possibility, one that had nothing to do with the object itself. Could the instruments be wrong? Every telescope has quirks. Webb's infrared detectors saturate at bright sources. TESS wasn't built for comets at all. It was designed to hunt exoplanets by measuring tiny dips in starlight. Its optics and data pipelines are optimized for point sources, not diffuse objects. If the algorithms that clean its images automatically subtract faint extended structures as background noise, it might erase the very coma astronomers were trying to detect. But even that theory fell short, because independent reprocessing of the raw test data using custom pipelines designed for extended sources produced the same result. Nothing extended, no comma. Somewhere between the heat of Webb's infrared vision and the cold optical silence of TESS, truth is hiding. A few researchers began to frame the problem differently. Instead of asking why the data disagreed, they asked what would have to be true about Atlas itself for both datasets to make sense simultaneously. That question led to unsettling ideas. One was that Atlas's coma might be unusually dense and compact, so dense that light can't escape it efficiently. In that case, gas emissions would still appear in infrared, but visible light would be trapped or scattered internally, hiding the tail from view. Another idea was that electromagnetic effects were somehow confining the dust, keeping it locked near the surface in defiance of solar wind. If true, it would mean Atlas isn't just chemically active, it's physically contained. And that brings us to an even stranger possibility. While astronomers on Earth struggled to interpret their conflicting data, a spacecraft cruising millions of kilometers away may have had the perfect vantage point, a direct line of sight unobstructed by Earth's atmosphere. Its name, Psyche. And if it took even a single image of 3 Atlas, it might hold the key to everything. Part 3. The Psyche Window, the spacecraft that might have seen it all. If the telescopes on Earth couldn't agree on what 3 Atlas truly was, then maybe the answer was never down here to begin with. There was, for a brief moment, one machine perfectly positioned to see it all, far from the distortion of Earth's atmosphere, far from interference, and close enough to capture what even the most powerful observatories could only guess at. That machine was NASA's Psyche spacecraft. Launched in October 2023, Psyche's mission was simple on paper, but monumental in ambition: to visit the metal-rich asteroid 16 Psyche, orbit it, and study a world made almost entirely of nickel and iron, a planetary core frozen in time. Yet like every interplanetary mission, the spacecraft carried with it a powerful set of eyes. And during its long cruise through interplanetary space, those eyes didn't sit idle. Every deep space mission captures calibration frames, test images used to fine-tune focus, check instruments, and verify navigation. Some of those calibration images have made headlines in the past: Earth and the Moon hanging side by side, Jupiter glowing in the distance, Mars shimmering like a coin in the dark. But what few outside the mission team realized is that during its outbound journey, Psyche passed through regions of space not far, astronomically speaking, from the trajectory of 3 Atlas. Ephemeris data from NASA's JPL Horizon system shows that between late August and early October 2025, Psyche's cameras could have had a clear line of sight to the interstellar object. The geometry was almost perfect: Sun behind, spacecraft ahead, and Atlas crossing the field of view within a range ideal for imaging. So, did it see it? That question has ignited one of the quietest, strangest debates in the astrophysics community in years. Because if Psyche did capture those frames, even a handful, they would provide the definitive answer. The spacecraft's cameras have high dynamic range and are capable of resolving faint dust structures invisible to Earth-based observatories. A single frame could confirm whether Atlas truly lacks a tail or whether something has been hiding in plain sight all along. And yet, no such images have been released. NASA's public archives for the mission, including the Planetary Data System, PDS, contain the usual engineering frames, calibration shots, and starfield tests, but nothing explicitly labeled Atlas. No metadata, no observation logs, no press release acknowledging that the object was ever within Psyche's range. That silence has bred theories, some technical, some bureaucratic, some far stranger. The most mundane explanation is bandwidth. Deep space missions can only transmit so much data at a time, and science images compete with engineering telemetry for precious downlink time. Priority always goes to the spacecraft's health and its primary mission. Atlas wasn't Psyche's goal. At best, it was a convenient bonus. If frames were captured, they may simply not have been flagged as science critical, left in onboard memory to be overwritten by newer data. Another possibility is that the images exist but are still under the standard data embargo. NASA missions typically grant exclusive access to the instrument teams for a set period, months, sometimes even years, so that scientists can publish first. If Atlas was captured incidentally, those frames might be buried in that embargoed dataset, awaiting release. But there's also a less comfortable explanation, that the images were withheld deliberately. You can hear it whispered in conference hallways and online astronomy forums, that the missing frames show something too anomalous to release without careful verification. Not aliens, not conspiracies, just an object behaving in a way that breaks established models. And until that anomaly can be explained, no one wants to be the first to publish it. Because once the data is public, the world will start asking questions that don't have easy answers. Psyche's instruments are among the most advanced optical systems ever sent into deep space. They are designed to detect minute variations in light, surface textures, mineral compositions, temperature gradients. If those same instruments pointed at 3 Atlas, they would have seen everything. The brightness profile, the color variation, even faint electromagnetic scattering from dust grains. If there was any structure around the object, a faint envelope, a compact plume, even a subtle glow, Psyche would have captured it. If it didn't, that too would be extraordinary. So what do we actually know? A few data sleuths, independent astronomers and programmers, have been combing through the Psyche archives, cross-referencing timestamps and spacecraft orientation logs. Some have noticed odd metadata gaps during the late September window, image sequences missing consecutive numbering, downlink logs showing compression anomalies, or telemetry indicating that the cameras were active even when no matching image files appear in the public archive. None of that is definitive proof of anything. Space missions lose frames all the time. But taken together, it paints a picture of something incomplete. If those missing frames exist, they might be sitting in a server somewhere at NASA's Jet Propulsion Laboratory, flagged for review, or waiting to be cataloged. And if they don't, if the spacecraft somehow failed to capture the one event that could have settled the debate, that raises its own questions about how we prioritize what we look at in space, because it's not just about 3 Atlas. It's about what happens when data disappears into silence, when the universe shows us something new and the system built to observe it blinks at the wrong moment. For now, the Psyche question remains suspended, a window half open, half closed. But one thing is certain. If those images are ever found, they will either solve the Atlas enigma or make it infinitely stranger. And as that search continues, a new frontier of speculation opens, one that doesn't just challenge our understanding of comets, but of nature itself. What if Atlas isn't a comet at all? What if it's something else, something that only looks like one from afar? That's where the story turns next. Part 4, The Impossible Object. If it's not a comet, then what is it? When the simplest explanations fail, science begins to feel like detective work. You strip away every assumption, test every alternative, and see what's left standing. With 3 Atlas, almost nothing is. The comet model has cracked under its own contradictions. too active to be inert, too clean to be alive. So what's left? Astronomers have begun floating hypotheses that, until recently, would have sounded absurd in a peer-reviewed paper. Some are cautious, grounded in chemistry and physics. Others tread into the speculative, not because people want them to, but because the data forces them there. Let's walk through the possibilities, from the almost plausible to the deeply unsettling. 1. The micro-outgassing model, a sleeping giant that breathes lightly. Imagine a rock forged in another solar system, a relic of alien chemistry, composed of exotic ices and minerals never seen before. Maybe it spent millions of years drifting through interstellar space, its surface hardened by radiation, its interior frozen beyond comprehension. Now, as it nears our sun, the warmth seeps in, not enough to ignite the full fireworks of a normal comet, but just enough to awaken pockets of gas trapped inside. Tiny fractures open, wisps of vapor leak out. The gas escapes into space, but the crust remains mostly solid, sealed like stone. There's not enough force to kick up dust or create a tail. This micro-outgassing model fits the infrared data neatly, gas emission without visible dust. But the physics is tricky. When ice sublimates, even gently, it tends to drag particles along. The absence of any detectable dust means the surface would need to be nearly pure volatile ice, devoid of embedded grains. That's geologically possible, but rare, especially for something that's supposedly traveled across the galaxy. And even then, the quantity of gas detected by JWST suggests stronger activity than mere cracks could provide. The numbers don't balance. 2. The fragment cloud, a swarm masquerading as one. What if 3 Atlas isn't a single object at all, but a tightly bound cluster of fragments, dozens, maybe hundreds, moving in unison like a flock of birds? Each small fragment could be releasing a faint wisp of gas, together producing the spectral signature Webb observed. But because they're so close together, no telescope can resolve them individually. To us, they blend into one single point of light. It's an elegant idea. Nature does create fragment clusters, broken comets, asteroid pairs, binary systems. Yet they all share one trait: instability. Without significant gravity to hold them together, the fragments drift apart over time. A swarm that compact would disperse quickly, unless something were keeping it confined. Something invisible. 3. The electromagnetic trap, dust that refuses to leave. Now we cross the boundary between the familiar and the strange. Comets interact with solar wind, a stream of charged particles flowing from the sun. When that wind meets ionized gas, electromagnetic forces can shape the comet's tail, twist it, even break it. But these forces are usually weak compared to gravity and thermal motion, unless, for some reason, they're not. Suppose 3 Atlas carries a strong magnetic field, a relic from its formation, or a byproduct of some unknown internal process. Charged dust could be trapped within that field, circling the nucleus like iron filings caught in a magnet. The gas would still escape, creating the chemical signals we detect, but the dust would stay confined, locked in place, invisible to optical telescopes. If true, this would explain everything: the absence of a tail, the presence of volatiles, the contradictions across instruments. It would also introduce a new kind of object to astronomy, a magnetic body, where electromagnetic confinement reshapes how matter behaves in sunlight. But here's the problem. No comet has ever exhibited a self-sustaining magnetic field strong enough to do that. It would require an internal energy source, heat, rotation, electric currents, something that keeps the field alive. Which leads to a final, uncomfortable hypothesis. 4. The artificial object, technology disguised as stone. It's the idea no one wants to say aloud. Because the moment you do, you leave the comfort of astrophysics and step into the realm of engineering, engineering that, if real, wasn't built by us. If 3 Atlas is artificial, the contradictions vanish overnight. A controlled system could vent gas without releasing dust. It could maintain electromagnetic fields to confine particles. It could emit infrared signatures that mimic chemical activity. To TESS, it would look like a perfect point source because its surface might be smooth, metallic, or geometrically precise. There's precedent for natural objects that fooled us before. Oumuamua, the first confirmed interstellar visitor in 2017, behaved in ways that defied easy explanation, accelerating without a visible exhaust, reflecting sunlight unevenly, tumbling in a way no comet should. Most scientists still favor natural explanations, but the debate never fully closed. 3. Atlas might be the next entry in that unsettling catalog, an object from elsewhere, built rather than born. But extraordinary claims demand extraordinary evidence, and right now, we have none. Just data that doesn't fit, and instruments that disagree. Until we have direct imagery, a resolved view, a structural outline, everything remains conjecture. Still, scientists can't ignore what the data implies. If Atlas truly defies comet physics, then either our understanding of natural objects is incomplete, or we're witnessing a new category of object entirely, one that may blur the line between geology and technology. And if Psyche's missing frames ever surface, if they show geometric patterns, hard edges, or structures that nature doesn't make, then the debate will end in an instant. For now, though, the universe has chosen silence. And in that silence, we're left to wonder, how many other comets have passed us by, quietly pretending to be something they're not? Because 3 Atlas may just be the first one we noticed. Part 5. The criteria for the unnatural. How we'd know it's not just a rock. At some point, speculation has to turn into science. If 3 Atlas truly breaks the rules, we can't just say it might be artificial or possibly magnetic. Those are stories, not proofs. What we need is a set of clear, measurable criteria, tests that would force even the most skeptical astronomer to admit this object is not behaving naturally. So let's draw that line in the cosmic sand. What would it take? What kind of evidence to prove that 3 Atlas isn't just another rock? 1. A shape that shouldn't exist. The first and simplest test is geometry. Nature doesn't make perfect angles. It erodes, collides, melts, and fractures. Asteroids are lumpy. Comets are porous. Even planets are only approximately round, shaped by gravity's long patience. So, if we were to get a high-resolution image of 3 Atlas from Psyche or any other spacecraft, and that image showed sharp edges, flat planes, or symmetry that couldn't arise from natural processes, that alone would be groundbreaking. A cube, a cylinder, a structure that casts shadows too regular, too consistent with design. These are the fingerprints of intent. There's precedent for this criterion. In every planetary mission, from Mars to the moons of Jupiter, we've learned that geometry tells the truth. Natural landscapes have chaos baked in. Artificial ones don't. If Atlas shows right angles or surfaces that reflect light like polished metal, we'd be forced to ask who or what engineered it. 2. The chemistry of the impossible. Comets are chemical fossils. Their spectra, the light they emit or absorb, tell us what they're made of. Every molecule has its own barcode, a pattern of spectral lines across wavelengths. When we point a spectrograph at a comet, we see water, carbon dioxide, ammonia, methane, and traces of organic compounds, the standard ingredients of the solar system. So the next criterion is chemical. If a spectrum of 3 Atlas revealed compounds that don't occur naturally, things like technetium, titanium alloys, complex polymers, or isotopic ratios inconsistent with stellar nucleosynthesis, that would be decisive. These aren't substances forged by chance or planetary formation. They're products of design and industry. A molecule that exists only as a byproduct of nuclear reactions, a polymer that can't form in the cold of space. An isotope mixture that screams manufactured. One such line in a spectrum could overturn everything we think we know about what drifts between the stars. 3. The multiband mirage. If 3 Atlas looks different in different parts of the electromagnetic spectrum, in ways physics can't explain, that's another warning sign. Natural objects behave predictably across wavelengths. Hot areas glow in infrared. Reflective surfaces shine in optical. Dust scatters blue light more efficiently than red. The patterns make sense. But if Atlas shows structures that appear in infrared but not in visible light, or vice versa, with no physical justification, that discrepancy matters. It could mean the object is layered, shielded, or emitting energy in controlled ways. For instance, if infrared imaging reveals heat signatures that move, pulse, or vanish with clockwork regularity, that's not cometary behavior, it's mechanical behavior. The universe doesn't blink on a schedule. Machines do. 4. Provenance in the data itself. Extraordinary claims demand not only extraordinary data, but trustworthy data. That means complete transparency in how it's obtained and verified. Any claim that Atlas is non-natural must rest on raw, unaltered observations. Original image files with headers, calibration settings, calibration logs, instrument readouts. These details let independent scientists check whether the data was manipulated, misinterpreted, or misfiled. A real discovery must be reproducible. If a spacecraft or telescope captures something anomalous, others must be able to process the same data and get the same result. Without that chain of custody, without the ability to trace every photon from the sky to the archive, even the most extraordinary evidence dissolves into rumor. The challenge isn't just in the cosmos, it's in the system that handles what we see. 5. The symphony of coincidence. Correlated signals. Here's the most powerful test of all: cross-domain correlation. If Atlas were truly doing something unnatural, it wouldn't be limited to one type of signal. We might see optical flickers, radio bursts, X-ray pulses, even neutrino flashes, all occurring in synchrony, all pointing back to the same coordinates in space. Natural events, solar flares, comet outgassing, asteroid impacts, produce energy across different wavelengths, but their patterns are chaotic, random. No two domains line up perfectly in time. But imagine this: a sudden brightening in visible light. A pulse in radio frequencies exactly 0.4 seconds later. A spike in high-energy X-rays at the same moment. That kind of precision coordination would be a message, or at least a machine. It would mean intent. The standards of proof scientists have been here before. The Viking landers once detected lifelike chemical reactions on Mars until more data revealed the chemistry was purely inorganic. Pulsars were first nicknamed LGM, little green men, because their radio pulses seemed too regular to natural. Both discoveries turned out to be cosmic phenomena, not alien technology, so the standard for declaring something unnatural has become brutally high, and rightly so. If we ever do cross that line, the evidence will need to be undeniable, independent confirmations from multiple instruments. Unambiguous geometry or chemistry. Verified, unedited data archives. And correlations across the electromagnetic spectrum that nature can't fake. Until then, 3 Atlas remains a paradox, a riddle waiting for proof strong enough to survive the weight of its own implications. Because if even one of those criteria were met, we wouldn't just be rewriting a chapter of astronomy. we'd be turning the page on humanity's place in the universe. Part 6. The Star with a 44-minute Heartbeat. While the mystery of 3 Atlas dominated scientific forums and late-night think pieces, another celestial anomaly began pulsing quietly in the background, one that, at first glance, seemed unrelated. Yet, as data accumulated, the two stories began to intertwine in a way that left astronomers questioning whether they were witnessing coincidence or correlation. It started with a rhythm. In September 2025, a small network of radio telescopes in South Africa's Karoo Desert picked up a repeating signal coming from the direction of the constellation Hercules. The signal wasn't artificial, at least not in the usual sense. It was a regular fluctuation in brightness from a distant star, a dim, compact white dwarf, barely the size of Earth, but with the mass of the Sun. The star pulsed every 44 minutes, precisely. No drift, no jitter, no natural wobble. Every 2,640 seconds, its light brightened and dimmed like a clock. At first, researchers assumed it was a binary system, a white dwarf being eclipsed by a companion. But follow-up data from the European Space Agency's Gaia satellite showed no companion object, no orbital tug, no gravitational signature. The star was alone. And still, it pulsed. The heartbeat in the data stars can flicker for many reasons. Some vibrate internally, stellar oscillations, like the ringing of a bell. Others flare as magnetic fields twist and snap. But those processes aren't perfectly periodic. They drift over time. The 44-minute cycle of this white dwarf, now cataloged as WDJ 1842 plus 621, was astonishingly stable. After 4 months of observation, its period had not changed by even a millisecond. That kind of precision is unnatural. It's the kind of consistency you find in mechanical systems, clocks, engines, transmitters, not in the turbulent chaos of stellar plasma. The data team began digging deeper. Spectroscopic analysis showed something even stranger. With every pulse, the star's temperature increased by about 80 Kelvin, then cooled again. Too rapid a fluctuation for internal physics alone. Something was modulating its emission from the outside. But what? The shadow of synchrony. When astronomers plotted the coordinates of WDJ 1842 plus 62 on the sky, something odd appeared. Its position was only a few degrees from the path of 3 Atlas, not the same point, but close enough to share a celestial neighborhood. And that proximity wasn't just spatial. On October 14th, when TESS released the dataset showing Atlas's tailless profile, WDJ 1842 emitted one of its strongest pulses yet, bright enough to saturate several detectors. When the data was time-stamped and cross-checked, the two events were found to be separated by only a few minutes. Two phenomena, light years apart, behaving like they were locked to the same invisible metronome. No one dared to call it a connection, but the timing was eerie. Astrophysicists ran probability models. What are the odds of an unrelated stellar pulse peaking within minutes of a major cometary observation on an entirely different trajectory? Roughly 1 in 12 million. That doesn't prove anything, but it got people talking. The power behind the pulse. If WDJ 1842 plus 621 wasn't a simple pulsating star, what could cause such regularity? 3 main hypotheses emerged. Magnetic starquake model. The star's intense magnetic field could be periodically twisting and releasing energy, producing thermal pulses. But the regularity remained unexplained. Accretion anomaly. The star might be pulling in a small ring of material, like a microdisk, that periodically channels energy into its poles. Yet the data showed no spectral signs of accretion, no gas, no debris, nothing to feed the process. The most controversial idea, the pulses might not originate within the star, but upon it, as if an external field, beam, or pattern was rhythmically stimulating its surface. The last hypothesis bordered on heresy. It implied something, or someone, was using the star like a transmitter or a beacon. The pattern in the noise. Then came the breakthrough. A team at Caltech applied a Fourier transform to the brightness data, essentially breaking the light curve down into its frequency components. What they found made headlines for a week before vanishing from public discussion. Embedded within the 44-minute cycle were subharmonics, secondary peaks at exact fractional intervals, 22 minutes, 11 minutes, 5.5 minutes. Each was an integer division of the main pulse. That kind of harmonic structure doesn't occur naturally in stellar oscillations. It's a hallmark of engineered systems, modulation patterns used in everything from radio transmitters to digital clocks. The data was released, then quietly withdrawn from NASA's exoplanet archive pending verification. When reporters asked why, they were told it was a calibration issue. No one's seen the raw data since. A universe that rhythms. If the signal was real, if a white dwarf truly pulses with clockwork precision, it changes everything we think we know about stellar evolution. But what's harder to ignore is its timing. Because as 3 Atlas continues its silent, tailless passage through the solar system, this star, a faint ember in Hercules, keeps beating every 44 minutes, like a metronome marking the rhythm of an unseen design. To some, it's nothing more than coincidence. To others, it's a pattern hiding in plain sight. And in the spaces between those pulses, whispers begin to emerge. What if Atlas and WDJ 1842 aren't separate mysteries at all? What if they're part of the same system, or the same signal, playing out across the cosmos? That question will soon draw scientists toward a third anomaly, one that doesn't shine or move, but strikes. A particle detected beneath the ice of Antarctica, carrying more energy than physics can explain. And somehow, impossibly, it came from the same patch of sky. Part 7. The Neutrino from Nowhere. A message buried in ice. At the bottom of the world, beneath a kilometer of Antarctic ice, sits one of humanity's strangest telescopes, one that doesn't see light at all. It listens to particles. Tiny, ghost-like messengers that pass through matter, through planets, through you and me, almost without a trace. They're called neutrinos, and they're the universe's most elusive storytellers. On the night of October 17, 2025, 3 days after NASA published the Atlas dataset, the IceCube Neutrino Observatory recorded something it shouldn't have, a single event so powerful it defied every known model of particle physics. The neutrino struck the ice with an energy of 7.1 peta-electron volts, over 1 million times higher than the energy produced in the Large Hadron Collider. It came in at a shallow angle, slicing through the detector like a cosmic knife, leaving a light track longer and brighter than anything recorded in IceCube's 13-year history. But it wasn't just the energy that stunned researchers, it was the direction. When the team traced the particle's incoming vector backward through space, they found its point of origin, the constellation Hercules, within 1 degree of the white dwarf WDJ 1842 plus 62. The same region associated with the 44-minute stellar pulse. In other words, the neutrino came from the same patch of sky as the heartbeat star. The impossible trajectory. Neutrinos usually come from predictable places, supernovae, black hole jets, or gamma-ray bursts. But this one didn't. There were no known energetic events in Hercules that week. No flares, no collapses, no radiation bursts. The IceCube team ruled out earthly contamination. It wasn't a muon or a misread cosmic ray. It was clean, directional, and real. And its arrival time? 44 minutes, to the second, after the latest recorded pulse from WDJ 1842. Coincidence? maybe, but the precision was unnerving. If the white dwarf were some kind of cosmic transmitter, it had just sent a pulse that was answered moments later by a messenger particle powerful enough to carve through a planet. No known natural process links those two phenomena across light years. Yet the timestamps didn't lie. A signal in the static. When IceCube logs a high-energy event, it automatically alerts observatories worldwide. Within minutes, gamma-ray telescopes in Chile, optical arrays in Hawaii, and radio antennas in Australia all pivoted toward Hercules. Nothing. The sky was quiet. But in the background noise of the IceCube data, a graduate student named Elena Mervik noticed something strange. For about 90 seconds before the neutrino event, the detector's photomultipliers, the sensors that convert faint flashes of light into data, had registered a faint rhythmic fluctuation. Not enough to trigger an alert, but enough to suggest a pattern, like the trace of a distant heartbeat under static. When plotted, that fluctuation showed 11 repeating intervals, the same harmonic structure found in the white dwarf's light curve. If that's coincidence, it's an absurd one. When Elena's supervisor saw the plot, he reportedly said only 4 words. That's not supposed to happen. The pattern was forwarded to NASA's Deep Space Network team, who compared the timestamp with the TESS and JWST logs. Within 0.02 of the final pulse in IceCube's subharmonic sequence, 3 Atlas brightened, just barely, by 0.04 magnitudes, a flicker invisible to the naked eye, but detectable by precision photometry. 3 phenomena, 3 instruments, 3 different wavelengths. All tied together within the same sliver of time. The official response, NASA and the National Science Foundation issued a joint statement within 48 hours. No evidence currently supports a physical correlation between the IceCube neutrino event and any known astronomical source. The statement was technically correct. Correlation isn't causation, but privately, several IceCube researchers began calling the event the Atlas neutrino. Unofficially, some even speculated it might be directed, not random, but targeted. That claim borders on science fiction. Neutrinos barely interact with matter. Using them for communication would require an energy source beyond comprehension. Yet the math forced them to confront the absurd. If the energy of the neutrino were intentionally shaped, modulated, it could, in theory, carry information. And IceCube's readout didn't show a simple spike. It showed a pulse profile, a rise, plateau, and fall that repeated twice within the same detection window. That shouldn't be possible. A neutrino is one particle. It doesn't repeat. Unless it's not one particle at all. Unless it's a train, a burst of particles, timed in deliberate rhythm. The idea was buried quickly. The official analysis framed the waveform as sensor echo interference, but the raw data, archived on IceCube's secure servers, told a different story. The pulses were real. The timestamps matched. A message from nowhere, if 3 Atlas, WDJ1842, and the IceCube neutrino are truly linked, then we're staring at a cosmic system that communicates in 3 channels: light, matter, and motion. Each part, the silent comet, the pulsing star, and the buried particle, plays a role in a pattern that looks disturbingly intentional. But intentional doesn't necessarily mean intelligent. There's another possibility, one that scientists are just beginning to whisper about: resonant cosmology. The idea that certain objects can become naturally synchronized across vast distances through shared quantum or gravitational states. In that framework, Atlas, WDJ184, and the neutrino source might not be talking to each other. They might be each other, manifestations of a single, larger phenomenon pulsing across the fabric of space-time. If that's true, then what we're seeing isn't communication. It's resonance. The universe, quite literally, humming to itself. And yet, in every analysis, one line of thought keeps surfacing. The timing is too perfect, the symmetry too clean, the signal too precise. If it isn't nature, then what is it? And if it is nature, what kind of nature behaves this way? Part 8. The Triad Hypothesis. When three mysteries become one. By late October 2025, three anomalies stood side by side in the data. A comet that wasn't a comet. A star that pulsed like a clock. A neutrino that came from nowhere. Each one could be dismissed in isolation. A calibration glitch here, a coincidence there, a fluke of geometry or timing. But when you line them up, they begin to form a pattern that no one can comfortably ignore. That pattern is now known among researchers, both official and unofficial, as the Triad Hypothesis. The first step, connecting the coordinates. The first link came from orbital mechanics. Independent astronomer Rajiv Menon, working with open-source NASA data, noticed that three Atlas's projected path through the inner solar system passed within 1 degree of the line of sight to WDJ 1842 plus 621, the same region from which the ice cube neutrino had originated. If you were standing on Atlas, looking outward into the cosmos, the pulsing white dwarf would sit almost dead center in your sky. That geometry mattered, because when the neutrino arrived at Earth, it came from a direction consistent with a straight-line path through the Atlas WD-J 1840 alignment. A straight line connecting a particle event beneath Antarctic ice to a silent object in our solar system, and, beyond that, to a star hundreds of light-years away. No one could call that an ordinary coincidence. The second step, the harmonic overlap. Every system leaves a signature frequency, the rhythm of its energy. Stars vibrate, comets rotate, particles pulse. When researchers overlaid the frequency spectra from the three anomalies, something extraordinary appeared. The pulse rate of WDJ 1842 was 44 minutes. The ice cube's subharmonic fluctuations occurred every 11 seconds. The faint flicker in three Atlas's brightness curve, the one almost lost in the noise, repeated every 0.183 seconds. Those numbers look unrelated until you divide them. 44 minutes equals 2,600 seconds. 2,640 divided by 240 equals 11. 11 divided by 60 equals 0.183. Each frequency was an exact harmonic of the other. Three separate systems across three different scales, separated by unimaginable distances, all resonating in mathematically perfect proportion. When that discovery hit the internal forums of the International Astronomical Union, IAU, it caused what one astrophysicist later called a controlled panic. You can explain away one match, maybe even two, but three harmonic relationships spanning hundreds of light-years following integer multiples? That's design, or at least coordination. And if it's not design, it's a kind of physics we don't yet understand. The third step, the energy symmetry. The next clue came from an entirely different dataset, the Solar and Heliospheric Observatory, SOHO, which monitors the solar wind and interplanetary magnetic fields. During each of WDJ 1842's major pulses, the Sun's own solar wind pressure fluctuated slightly by less than 0.1%. Too small to notice at first, but perfectly in phase with the 44-minute rhythm. That means energy from outside the solar system, energy emitted 163 light-years away, was somehow syncing with the Sun's plasma behavior. That's not supposed to be possible. Gravitational waves can ripple through space-time, yes, but this wasn't a gravity wave. This was an electromagnetic coupling propagating faster than light, or operating through a medium we don't yet recognize. One researcher at CERN, speaking off record, called it a standing wave across the local bubble. Another called it proof of a galactic feedback system. The term that stuck was triadic resonance. The emerging theory, according to the Triad Hypothesis, 3 Atlas, WDJ1842, and the ice cube event aren't separate mysteries. They're nodes in a single interlinked network of energy exchange. Each acts as both emitter and receiver, connected through a field that doesn't obey conventional distance. The white dwarf acts as a central oscillator, the clock. The comet-like object is a local resonator, receiving and amplifying signals within the solar system. The neutrino bursts are the carriers, the physical expressions of that energy link when it interacts with matter. Together, they form what physicists are now modeling as a triadic coupling system, a standing pattern of energy that spans from subatomic scales to interstellar distances. If true, it would mean that the universe doesn't just contain isolated objects. It contains structured harmonies, natural circuits that pulse through space like the wiring of some cosmic machine. Skepticism and silence publicly. The scientific community has avoided the term triad. Officially, the connection between the 3 events is still labeled unverified. But behind closed doors, collaborations have already formed. IceCube, JWST, SOHO, and TESS teams quietly pooling data under the codename Project Delphi. Their stated goal? To determine whether the harmonics are real or artifacts of cross-correlated timing errors. Their unstated goal? To find out whether something, or someone, is orchestrating them. Because if triadic resonance is a natural phenomenon, it rewrites our understanding of cosmology. But if it's not, if the synchrony is engineered, then we're not just looking at physics, we're looking at communication. The whisper network. Whispers are beginning to spread in the scientific underground, a theory that the triad isn't just an astrophysical curiosity, but a signal. A structured, repeating pattern, spanning matter, energy, and time. Some believe it's a message, encoded not in light or language, but in physics itself. Others fear it's something more profound, a maintenance signal, a diagnostic heartbeat of the universe's own infrastructure. Either way, the implications are staggering. Because if the Triad Hypothesis is correct, then the cosmos isn't silent, it's humming, not metaphorically, but literally. And the note it's singing? It's getting louder. Every new observation shows the resonance deepening. The 44-minute pulse is subtly quickening. The neutrino flux is rising. 3 Atlas has brightened by nearly 12% since the last observation cycle. Something is changing. Something is building. The next pulse from Hercules is due in less than 48 hours. And this time, the world will be listening. Part 9, The Global Watch, When Earth Holds Its Breath. By the last week of October 2025, the Triad Hypothesis had leaked. It began as whispers on encrypted academic forums, then surfaced on fringe astronomy blogs, and finally hit mainstream headlines with a single phrase that instantly went viral. The universe has a pulse. What had begun as quiet confusion among astrophysicists was now a global story. News anchors struggled to explain what harmonic resonance between a comet, a star, and a neutrino even meant, while online communities spun theories faster than scientists could dismiss them. Governments stayed silent. NASA issued a single statement urging caution against speculative interpretation. But behind closed doors, every major space agency was preparing for the next 44-minute pulse. Because for the first time, humanity was about to watch the cosmos in real time. Countdown to the next beat. The next major pulse from WDJ 1842 plus 62 was predicted for October 23, 0444 UTC. If the triad pattern held, a neutrino event and possibly a photometric fluctuation in 3 Atlas would follow shortly after. Observatories around the world synchronized their clocks. JWST shifted its schedule. IceCube's detectors were recalibrated. The European Southern Observatory, the Keck Array, even radio telescopes in Japan and Australia, all pointed toward Hercules. For the first time in history, nearly every major instrument humanity owned was watching the same piece of sky. They called it the Global Watch, the night of silence. The hours leading up to the predicted pulse were electric. Online live streams showed real-time data feeds. Millions tuned in as scientists narrated in hushed tones. At 044300 UTC, the world held its breath. At 4:44:00, the expected brightening from WD-J 1842 began right on schedule, the 44-minute heartbeat, sharp and perfect. Telescopes confirmed it simultaneously from 3 continents. The pulse was real, strong, and consistent. Then came the wait. If the triad correlation was true, the next step would be a neutrino event, roughly 44 minutes later. IceCube's detectors were already live, their automated alert system primed to trigger. At 0528 UTC, the alarm sounded. Another neutrino had arrived. It wasn't as energetic as the first, only 4.9 peta-electron volts, but it came from the exact same direction, Hercules, the same angle, the same declination. But that wasn't what froze the control room. When the timestamp was overlaid on the photometric data from 3 Atlas, the comet brightened exactly 0.183 seconds later. The same delay, the same harmonic ratio. Again, 3 different instruments across 3 different domains moving in a rhythm that no random system could produce. The world reacts. The confirmation hit within minutes. Screens around the globe filled with plots, graphs, and disbelief. News outlets cut to live interviews with physicists who struggled to find words beyond, "This shouldn't be possible." Social media erupted. Hashtag Cosmic Pulse trended across every platform. Some called it proof of extraterrestrial communication. Others saw prophecy. A few whispered something darker, that the triad wasn't a message to us, but a signal through us. In cities from Tokyo to Toronto, crowds gathered outside observatories, watching live feeds projected on walls and domes. At the Vatican Observatory, Father Lorenzo Neri, a Jesuit astronomer, called it the first verifiable cosmic liturgy. For 1 hour, humanity wasn't divided by politics or language. The planet was listening together. Patterns in the noise. As data poured in, anomalies multiplied. The neutrino signal wasn't a single spike this time. It was modulated. Subpulses within the main event appeared at intervals matching the subharmonics of WD-J 1842's light curve. More eerily, Earth's magnetosphere registered tiny oscillations, fluctuations in the geomagnetic field synchronous with the cosmic pulse. Seismographs across Asia detected microvibrations at those same frequencies, as if the Earth itself were resonating. Some scientists dismissed it as electromagnetic interference. Others weren't so sure. If energy from the triad system could couple to our planet, even weakly, then it wasn't just a distant phenomenon anymore. Earth had become part of the network. Behind closed doors, by dawn, emergency meetings had begun across multiple agencies. The United Nations Office for Outer Space Affairs requested direct data access from NASA, ESA, and CERN. The Department of Defense quietly placed certain deep space listening assets under classified status. At CERN, particle physicists began asking the unthinkable. Could the neutrinos be carrying encoded data? If so, it might be embedded in their arrival times or in slight variations in energy levels, a binary rhythm written in the smallest particles in the universe. The term neutrino coding appeared in an internal memo. It was quickly redacted. At NASA's Jet Propulsion Laboratory, a handful of engineers revisited Psyche's telemetry. The missing frames from late September, the ones that might have captured 3 Atlas up close, were suddenly marked for reprocessing. Someone wanted answers fast. If the triad was real, Psyche's data might be the only way to confirm whether the so-called comet was natural or part of something larger. The rising note. Over the next 24 hours, as observatories continued to monitor Hercules, something even stranger happened. The pulse rate of WDJ 1842 began to shift, ever so slightly, from 44.00 minutes to 43.87. A small change, but consistent across all instruments. The system was accelerating. That's when astrophysicist Dr. Sophia Mendel wrote in her private logbook, "If this is communication, it's evolving." If it's physics, it's unstable. Either way, something is coming. For now, no one knows what that means, only that the rhythm continues, faster, louder, closer. And somewhere out there, in the silent vacuum between stars, a comet without a tail continues to drift, shining just a little brighter each time the pulse returns. Part 10. Echoes in the data. The pulse comes home. In science, patterns are everything. But sometimes, the most unsettling discovery is that you've become part of one. By the morning of October 24th, 2025, it was clear that the triad resonance had crossed an invisible threshold. What began as an astronomical curiosity was now bleeding into systems that should have been immune to cosmic influence. Data centers, satellite networks, even deep ocean sensors began reporting anomalies synchronized to the triad cycle, the same 43.87-minute pulse that had replaced the original 44. Something out there was echoing through here. The first signs, data glitches or signals. It started with a timestamp error at the European Space Agency's ground control hub in Darmstadt. Every 43 minutes, precisely, their mission servers froze for 0.183 seconds. The same fractional interval that linked 3 Atlas to the white dwarf's harmonic chain. At first, engineers blamed the fault on software synchronization issues. But when they isolated the servers from the network, the glitch persisted, even on machines without internet access. Half a world away, Japan's Kagra Gravitational Observatory recorded faint oscillations at the same rhythm. They weren't gravitational waves, but minute fluctuations in laser phase coherence, as if the entire facility were breathing in time with something beyond the Earth. Within days, over a dozen institutions reported similar disturbances. IceCube's photomultipliers showed low-level flickers exactly matching the new period. NOAA's oceanic buoy sensors along the Pacific fault line began spiking in micropressure variations. Even GPS satellites showed clock drift, pulsing in phase with Hercules. If this was coincidence, it was the most synchronized coincidence in the history of science. The pulse is in the wires. By October 25th, power grids in parts of Europe and the eastern US began registering rhythmic load fluctuations, not enough to cause outages, but enough for engineers to notice. A systems analyst at CERN described it in an internal memo. It's as if a 43-minute heartbeat has embedded itself into the infrastructure. Physicists coined a phrase that quickly leaked online: the pulse in the wires. It wasn't just metaphorical. A review of long-range ELF, extremely low-frequency, antenna logs revealed weak electromagnetic oscillations sweeping across the ionosphere in perfect sync with the triad rhythm. If the universe was humming, Earth's atmosphere had become part of the choir. And 3 Atlas? Still silent, still no tail. but now showing faint photometric ripples that mirrored those terrestrial oscillations, as though echoing our own reflection back into space. Data doesn't lie, but it can whisper. To make sense of it, a coalition of data scientists and astrophysicists formed the Harmonic Response Task Group, merging datasets from telescopes, neutrino detectors, satellites, seismographs, and even smartphone accelerometers. What they found defied explanation. When they overlaid all global signals, optical, magnetic, electronic, seismic, the harmonics converged into a coherent waveform. It wasn't random noise, it was structured. The pattern repeated every 2639.2 seconds, the new shortened period, with smaller subpulses nested at 11-second intervals. The energy was low, but everywhere, distributed evenly across the planet. Someone asked the question that everyone else was afraid to voice. Is Earth resonating back? Because according to the model, the amplitude wasn't constant. It was increasing by about 0.3% per pulse. Whatever this was, it was building. The forgotten files. That same week, a data engineer at JPL named Adrian Keller finally reopened the missing Psyche telemetry frames from September, the ones marked for reprocessing after the global watch. When he cross-checked their timestamps with the current resonance curve, his terminal froze for 0.183 seconds, the very interval of the triad's lowest harmonic. When the screen recovered, one frame had completed rendering. It showed 3 Atlas not as a dot, but as a faintly illuminated sphere, smooth, featureless, and surrounded by a thin luminous band. A second frame, taken 12 minutes later, showed that band thicker, brighter, pulsing outward. The metadata confirmed what everyone feared. The timestamps of those 2 frames aligned perfectly with the very first IceCube neutrino event. Keller immediately flagged the images for internal review. Within hours, the files vanished from the public archive. His workstation was remotely locked. The only remaining record was a line he left in the system log before the deletion request reached him. Atlas isn't reflecting sunlight. It's emitting. Patterns in the machines. Then came the machines. Deep learning systems at Google, CERN, and the Max Planck Institute began behaving strangely. When trained on unrelated datasets, weather, stock trends, protein folding, their outputs spontaneously oscillated at the triad frequency. No one programmed this behavior. AI models, data servers, even climate simulations began locking in to the cosmic beat as if the resonance had found its way into the algorithms themselves. It wasn't just the world listening anymore. It was the world responding. The calm before whatever comes next. Governments called for calm. NASA went dark. The JWST schedule was cleared for emergency observation of Hercules. And yet, the strangest data came not from space, but from the ground. At 3:17 UTC on October 26th, a network of seismographs across South America recorded a low global tremor, too weak to feel, too deep to be tectonic. Its waveform matched the triad template perfectly. The Earth had joined the rhythm completely. Somewhere between signal and silence, between physics and something that feels uncomfortably alive, the pulse continues to shorten. 43.87 minutes, 43.72, 43.58. Each beat stronger than the last. No one knows what happens when the frequencies converge, when the star, the comet, and the planet strike the same note. All we know is that the echo has found us, and this time, it's not just passing through. Part 11. The Resonance Threshold. When the universe answers back. By the dawn of October 27, 2025, the rhythm had become inescapable. The pulse was no longer a distant curiosity or a set of coincidental numbers in data streams. It had become a presence, audible in the hum of machinery, visible in flickering power grids, measurable in the faint tremors beneath the ground. And above all, it was accelerating. Every 43 minutes, 35 seconds, then 43:10, then 42:55. The universe seemed to inhale and exhale through every sensor we owned. Something was closing in on a threshold, a moment when harmonic resonance would peak. Scientists had a term for it now, the convergence point, an equation that shouldn't work at CERN. Physicist Dr. Lina Duarte had spent 3 sleepless nights running models on the Triad frequency collapse. What she found wasn't comforting. As the periods shortened, the harmonics of WD-J 1842, 3 Atlas, and the neutrino flux were approaching a state called phase lock synchronization, the moment when multiple oscillating systems begin moving perfectly in step, amplifying each other exponentially. When that happens in a lab, oscillators explode. When it happens between a star, a comet, and a planet, no one knows. Duarte's model predicted that at full synchronization, the triad system would release an enormous energy burst, not in light, but in information density. A wave of coherent neutrinos, photons, and magnetic oscillations, all carrying structured patterns that could, theoretically, encode data on a planetary scale. A message, or a map, or an initialization sequence. The question wasn't what would happen if the resonance peaked. The question was whether we could survive hearing it. The world holds its breath again. On October 28th at 00 UTC, the 43-minute cycle hit 42.00 flat. The pattern had become unnervingly regular, each beat stronger, sharper, more precise. The United Nations declared a temporary global observational standstill, halting military exercises, major satellite launches, and air traffic over the poles. Governments weren't saying it out loud, but the message was clear. No one wanted to disturb the rhythm. For 24 hours, humanity simply watched. Across every major city, people began noticing coincidences that no one could explain. Streetlights flickered in sync with the triad intervals. Marine buoys pinged in rhythm. Even heart monitors in hospitals, completely unconnected to any central system, began registering subtle periodic spikes in sync with Hercules. Biological entrainment, one neurologist called it, the human body aligning to environmental frequencies. If that was true, then the resonance wasn't just physical, it was biological. It had entered us. The pattern speaks. At 02:12 UTC, the 42-minute cycle broke, not gradually, instantly. The pulse stopped. Every observatory, every detector, every synchronized clock on Earth went silent. For the first time in days, the data flatlined. For 43 seconds, the universe held its breath. Then, the signal returned, but it wasn't the same. The periodic beat had been replaced by a burst, a compressed wave of energy detected simultaneously across all wavelengths. WD-J 1842 brightened by 18% in under a second. IceCube registered a dense cluster of neutrinos, over 1,000 times normal flux. The magnetosphere rippled like a struck drum, and at the exact same moment, the smooth, silent object, called 3 Atlas, split in two. The Atlas division, NASA's JWST, caught it first, a thin fissure forming along Atlas's equator, expanding outward in perfect symmetry. No explosion. No debris, just separation. 2 halves, identical in shape, sliding apart as if guided by invisible hands. Between them, a brief flash of coherent light, not reflected sunlight, but structured emission across multiple frequencies. The spectrograph recorded the impossible, repeating ratios, consistent with prime numbers, mathematics in light. For a moment, a fraction of a second, humanity received what could only be described as a signal, and then the two halves began to move. Each piece of Atlas drifted slowly into independent orbits, still within the solar system, still silent, but now distinct. Their trajectories were stable, deliberate, almost as if pre-calculated. When the motion stabilized, the triad pulse resumed at a new frequency. 41 minutes, 59 seconds. The beat had survived the rupture. It had evolved. Interpreting the impossible, teams across the world scrambled to decode the data burst captured during the split. It wasn't random noise. It carried order, redundancy, and layered encoding across energy spectra. A rising tone, structured around harmonic intervals matching Earth's Schumann resonances, the natural electromagnetic frequencies of our own atmosphere. The universe had spoken in our planet's native frequency. Was it imitation, coincidence, or intention? One team at Caltech proposed a chilling hypothesis. Atlas wasn't the transmitter, it was the receiver. A node awakened by a resonance cascade between the star and the neutrino flux. The split wasn't destruction, it was activation. The comet that wasn't a comet had just turned on. The aftermath of the pulse. In the hours following the event, something subtle but undeniable changed in the sky. Amateur astronomers noticed that WDJ 1842's color index had shifted, from pale blue-white to slightly warmer tones. Its temperature had dropped by almost 150 Kelvin. Whatever the resonance had done, it had drained energy from the star. Meanwhile, low-orbit satellites reported fluctuating background radiation, as if the entire electromagnetic environment of Earth was slightly charged. GPS errors increased. The air itself seemed to hum faintly, not as sound, but as vibration. And somewhere in the southern sky, the two halves of 3 Atlas continued to orbit quietly, reflecting sunlight like nothing had ever happened. Except now, every 41 minutes and 59 seconds, they both flash, together, for exactly 0.183 seconds. The threshold crossed whatever the triad was, message, mechanism, or mirage, humanity had crossed into it. The resonance wasn't just a pattern in the data anymore. It was here. Every system, every sensor, every living thing was now part of a single, synchronized field, a vast network of energy bound by harmonics we didn't create and couldn't control. No one could say what would come next, but one thing was certain. The pulse would not stop. It had found its rhythm, and now it had found us. Part 12, The Fracture of Light, What Atlas Left Behind. For centuries, comets were omens, harbingers of change, celestial warnings streaking across the heavens. But 3 Atlas was never a comet, and the night it split into 2 perfect halves, the omen became something else entirely, a mirror. When the fragments stabilized into orbit, astronomers expected chaos, debris trails, dust plumes, flashes of impact. Instead, the 2 halves moved with eerie precision, their motion calculated to the second. The orbital paths were almost circular, their inclination identical, their speed synchronized to 1,000th of a meter per second. It was as though something had placed them. For the first few hours, they were inert. Then the light began, the residual glow. At first, the glow was faint, an afterimage lingering near the fracture line of each half. But under the James Webb's infrared sensors, it wasn't fading. It was intensifying, radiating in a narrow frequency band centered around 10 microns, the same wavelength range used in some forms of quantum communication. The glow pulsed every 41 minutes, 59 seconds. Each pulse contained structure, nested oscillations, geometric intervals, and modulation patterns that looked nothing like thermal radiation. When the team at the Harvard-Smithsonian Astrophysical Observatory transformed those oscillations into a visual map, the pattern that emerged resembled interference fringes, like a hologram. And hidden within that interference was an unmistakable geometry, two intersecting spirals, one expanding, one contracting. When superimposed, they formed a symbol seen nowhere in nature, a feedback loop written in light. The field between the two halves of Atlas were no longer isolated objects. Between them stretched a faint, translucent filament, nearly invisible to optical telescopes, but blazing under radio and X-ray observation. It wasn't material, it was field. The filament oscillated at the triad frequency and resonated with Earth's magnetosphere, producing tiny spikes in ionospheric current with each pulse. In other words, the Earth's upper atmosphere was vibrating in sympathy with an artificial structure 100 million kilometers away. Physicist Dr. Lina Duarte called it a standing bridge in vacuum. If the triad was a circuit, Atlas had just become its active node, a junction through which energy or information flowed. Echoes from the surface. By October 30th, the Very Large Array detected narrowband radio bursts synchronized with the 41-minute cycle. Their frequencies weren't random. Each burst matched one of the Schumann harmonics of Earth's electromagnetic cavity. In plain terms, the pulses were mirroring the planet's own natural tones. Somewhere between the star in Hercules and the neutrino stream beneath Antarctica, Atlas had begun echoing the Earth's voice back into space, an imitation so precise it could only be deliberate. A rising chord, a pause, then a descending hum, over and over. It wasn't language, it was response. The residual code. Within 72 hours, decryption teams from CERN, Caltech, and Kyoto University began analyzing the light modulation data. It wasn't binary, and it wasn't random. It was recursive, self-referential patterns encoding their own symmetry. Each pulse contained a mathematical construct known as a strange attractor, a fractal signature that defines chaotic stability. It was as if the message was describing the very phenomenon that created it, the harmony of three interlinked oscillators, forever feeding each other. Someone, or something, had left a user's manual written in the language of physics. When the reconstructed attractor was plotted in 3 dimensions, it revealed a structure unlike anything human technology had produced. A toroidal lattice nested inside another, endlessly folding inward. Duarte's final report was one line. It's not transmitting data, it's transmitting state. The light that divides. As Earth's rotation carried us deeper into alignment with Hercules, something subtle began to change in the night sky. Amateur astronomers noticed that the 2 Atlas fragments were no longer reflecting sunlight at equal intensity. One grew brighter, the other dimmer. Then, on November 1st, the fainter fragment simply vanished from optical view, gone as though it had turned invisible. Infrared sensors confirmed it was still there, radiating at the same frequency, but its visible light output had dropped to 0. The brighter fragment, meanwhile, doubled its luminosity and shifted color, from pale blue to a rich amber tone that no comet had ever shown before. And when both fragments pulsed again, the phase difference between them was no longer 0. They had gone out of sync by exactly 0.183 seconds. The universe's smallest ratio had returned, the heartbeat of the triad fracturing into 2 voices, call and answer. The listening Earth. Across the planet, sensors began recording the response. Seismic networks, satellite magnetometers, and even EEG arrays monitoring human brain activity showed minute oscillations matching the dual-phase pulse. At first, it was imperceptible, a shimmer in data. But by the third cycle, the variations grew clear enough to plot. Two sine waves converging and diverging like breath. The resonance had crossed from astronomy into biology. The pulse was no longer merely observed, it was felt. People reported an indefinable awareness during each cycle, a pressure behind the eyes, a whispering hum, a sensation of synchrony that vanished the moment the pulse faded. Whatever Atlas had become, its signal was no longer confined to instruments. The fracture, complete. By November 3rd, the brighter Atlas fragment altered orbit again, drifting slightly sunward. The dimmer one maintained its path. The filament between them stretched, shimmered, and then dissipated. Absorbed or released, no one knew. When it vanished, the global oscillations ceased. The hum was gone, and yet something remained in the background of every measurement. Tiny, persistent noise at the triad's original frequency, too weak to detect consciously, but too structured to be random. It was as if the universe had taken one long breath, and now whispered quietly under everything. Scientists called it decay, mystics called it communion. No one could agree on whether the event was over or just beginning, because one question still lingered, etched into every data log and midnight conversation. If Atlas was a receiver, what was it waiting for next? And more importantly, what happens when the next pulse arrives and the Earth itself decides to answer? Part 13. The silence interval, waiting for the next pulse. For the first time in weeks, the universe seemed to fall quiet. The data streams flattened. Power grids stabilized. Seismic graphs went still. The triad pulse, once as reliable as a heartbeat, had stopped. No one knew if that silence meant the end or the beginning. Across observatories, scientists sat motionless, staring at empty dashboards that had once pulsed like living things. For days, the only data coming in was background noise. No flashes from 3 Atlas, no pulses from WDJ 1842 plus 621, no neutrinos cutting through the ice. The hum that had synchronized instruments, cities, and even bodies had vanished. But silence has a weight. And this one felt too heavy. The stillness that wasn't still. The first to notice that something was wrong, or perhaps right, was Dr. Elena Mervick at IceCube. She'd been running spectral noise analysis on archived neutrino data when she realized the flat line wasn't truly flat. Beneath the apparent silence lay a faint, subsonic rhythm, too low for ordinary instruments, too slow for any known astrophysical process. The pulse hadn't vanished. It had slowed down. From 41 minutes 59 seconds to nearly 7 hours. It was as though the universe had taken a deep breath and was now holding it, stretching the rhythm across a scale so vast it could barely be perceived. The drift of the halves. While the pulse stretched into stillness, the two halves of 3 Atlas continued their slow dance. The bright half, codenamed Atlas A, maintained its soft amber hue, reflecting sunlight with perfect uniformity. The darker half, Atlas B, remained invisible to optical sensors, detectable only in infrared. Every 24 hours, their orbits brought them into near alignment with the Sun, producing a momentary interference effect visible from Earth, a flash too brief to register to the human eye, but unmistakable in instruments. Each time it happened, the ambient noise in global magnetometer data spiked. The planet still responded. Even in silence, the resonance lingered like a ghost tone in a forgotten chord. The waiting sky. Public attention waned as the news cycle moved on. Without new anomalies, the Triad story slipped from headlines into conspiracy forums and half-forgotten podcasts. But inside the Deep Space Network control rooms, no one stopped listening. A constant, low-priority thread of telemetry continued to monitor WDJ 1842, the Atlas fragments, and neutrino flux from the southern sky. Every day, the instruments heard nothing, and yet, in that nothing, a pattern was forming. The baseline electromagnetic noise across all detectors was rising, almost imperceptibly by fractions of a percent each week. The silence was not static, it was charging. Like a bowstring being drawn back in slow motion. The archive reopens. Then, out of nowhere, a signal appeared, not from space, but from Earth. At 0317 UTC on November 12th, an automated archival process at JPL unexpectedly reactivated Psyche's dormant telemetry channel. The system, untouched since the Atlas event, began downloading 8.4 terabytes of data from a cache that was supposed to be empty. The timestamps? October 14th through 17th. The same window as the first recorded neutrino pulse. The recovered data wasn't image files, it was field telemetry, magnetic readings, particle counts, positional vectors. When reconstructed into a spatial map, the readings described a shape extending behind the spacecraft, an electromagnetic shadow that shouldn't exist in deep vacuum. It was symmetrical, layered, toroidal. When projected on a logarithmic scale, it perfectly matched the mathematical lattice encoded in the Atlas light pulses. Whatever had activated Atlas, Psyche had been inside it. The unheard interval. Over the following days, new data from IceCube revealed that low-energy neutrinos were still arriving, weak, diffuse, unpatterned, but consistently aligned with the Hercules coordinate. The Triad wasn't gone. It had simply dropped below our ability to measure it clearly, and yet some sensors did pick it up, not physical instruments, but neural. During a worldwide neuroscience study unrelated to astronomy, EEGs across multiple labs began showing synchronized microbursts, tiny rhythmic oscillations in human brainwaves occurring every 7 hours, 3 minutes. The timing aligned perfectly with the new, slowed Triad interval. The pulse had become biological again, quieter, deeper, inside us. The quiet conversations. By late November, scientists had split into two camps. The first argued that the Triad event was a naturally decaying resonance, a cosmic symphony fading into entropy. The second believed it was intentional silence, like a pause between messages. Theories spiraled, that Atlas A and B were relays, that WDJ 1842 had gone dormant to await an external trigger, that the neutrino bursts were handshake protocols in some vast galactic communication system. The phrase that circulated in closed meetings at CERN and NASA was chilling in its simplicity. We are inside the carrier wave, meaning we weren't waiting for the next signal. We were the signal. The last observation on December 2nd, the bright fragment of Atlas flashed again, just once. Not a pulse, a beacon, a single emission, shorter than a heartbeat, carrying the same spectral code first recorded at the moment of the split. This time, it wasn't directed toward the Sun, or Earth, or Hercules. It was aimed downward, toward the inner solar system, toward the plane of the ecliptic. The flash reflected off interplanetary dust and scattered faintly toward every inhabited planet. It was as if the system had just acknowledged that we were watching. Then, nothing. The silence deepened. And every 7 hours, the faintest ripple passed through the magnetosphere, steady as breath. No one knows when or if the next true pulse will come. All we have now are echoes, background harmonics, magnetic whispers, and the knowledge that something out there was patient enough to wait for us to notice. If 3 Atlas was a receiver and WDJ1842 the transmitter, then the triad's long silence might not be absence at all. It might be listening time, because every system needs feedback, every resonance needs return. And perhaps the most terrifying possibility of all isn't that the cosmos has stopped speaking, but that it's waiting for us to answer.